Hey guys, Mr. Pusky here. Hope you're having a good day so far. We are getting into factoring now. We did some diamond factoring problems. This chapter is my favorite chapter, even though it is considered by many students to be the hardest chapter of the year. I really like it. I think that it's kind of fun to they're kind of like puzzles, like the diamond factoring problems to figure out what works and stuff. And when it finally works, it feels very satisfying. It's kind of like a puzzle. So we're doing 10.5 today. So let's go ahead and read the name of the lesson. Name of the lesson, ready? 1, 2, 3. Factoring trinomials. Essential question, ready? 1, 2, 3. Analyze diamond factoring and compare and contrast the terms. Okay, so we have a review here to kind of get us into the swing of this whole process. So what we're going to do is you learned the FOIL process in section 10.2. So we're going to FOIL this x plus 8 times x plus 2, okay? So first thing we're going to do is we're going to do x times x, and what is x times x going to be? That's going to be x squared. That's the first. Now we got to do x times the 2, and what is x times 2 going to be? That is 2x. Remember, you multiply x by everything in the other parentheses. Now we got to multiply 8 by everything in the other parentheses. What is 8 times x going to be? 8x. And what is 8 times 2 going to be? That's 16. Okay? And now, after we FOIL, we got to combine like terms. So we look for the biggest exponent first. What's the biggest exponent you guys see here? I see an x squared. Are there any other x squareds or no? Okay, are there any x's? Yep, there's x here and x here. Any constants or numbers by itself? There are, okay. So we're going to keep the x squared is going to stay the way it is. Plus, now we got, what is 2x plus 8x going to be? That's going to be what? That's going to be 10x. And what is, then the 16 is just going to come along too, because there's no other constants numbers to combine besides that. Okay? So what we're going to put here, I think these arrows are kind of goofy, but 10 is the sum of 8 and 2, and 16 is the product of 8 and 2. What does sum mean? Sum means what? Sum means addition. What does product mean? Product means multiplication. So this is kind of an important part of this chapter here, is that 10 is the sum. When you add 8 and 2, you get 16. Or when you add 8 and 2, you get 10, and when you multiply 8 and 2, you get 16. So, for example, this would be a diamond problem where we had 16 and 10, and then 8 and 2 would multiply to 16 and add to 10. Remember from the diamond problems? Okay? So, now we're just applying it to actual polynomials, which is going to be kind of exciting. So, all right, and the standard form for a polynomial is going to be ax squared plus bx plus c equals 0. That's going to be standard form for a polynomial. Okay? All right. Next, it says factoring a trinomial with a coefficient of 1 on the x squared. Coefficient is the number in front of the x squared, so basically that's going to be a, so a is going to equal 1, or just it's going to be x squared. Okay? So we're going to be, just kind of like right here, this would be a 1, or else it would just be x squared. All right? So we're going to undo the FOIL process. This is called general factoring too. General factoring. Okay? We are going to undo the FOIL process using our A, B, and C. We're going to find two numbers whose product, whose what? Is the last term, is the what? Whose product is the last term of the trinomial, and find two numbers whose sum, whose what? Is the middle. Is the what? The middle term of the trinomial. Okay? Another way to write this is that we're going to write, in quotation marks, factors of A times C that add to B. Factors of A times C that add to B. I'll put an exclamation point. That's really exciting. Okay? All right, we have some diamond factor problems. So we're just going to continue what we did before. Okay? So let's go ahead and see if we remember how to do this. So we need factors of 15 that are going to add to 8. So what are some things that multiply to 15? What times what is 15? Well, we got 1 and 15. Anything else multiply to 15? We got 3 and 5. Anything else? So those are the factors of 15. What adds to 8? This 1 and 15, are those going to add to 8 or no? And this is positive, so then both numbers have to be positive to multiply to positive 15. So we're going to do 3 and 5, right? The 3 and 5 add to 8 and multiply to 15? It does. So that would be 3 and 5 would be the correct numbers. What about for B? Now this time we're given the side numbers, so we just got to do what the side numbers tell us to do. So we're going to take these two, we're going to multiply to the top. So what is 3 times 1 going to be? That is 3. And then 3 plus 1 is going to be what on the bottom? It's going to be 4. Okay, the numbers on the side need to multiply to the top, they need to add to the bottom. And then if you recall a while ago, we had these kind of problems where we had, we don't know what this number is over here, so 5 times something equals 10, and 5 times what is going to equal 10? It's going to be 2, you can divide by 5 if you want, x equals 2, so this is 2. So then now we have 5 times 2 was 10, and on the bottom we're going to do 5 plus 2, which is going to be what? What's 5 plus 2? It is 7. Okay, so those diamond problems were important, and hopefully those are making sense. And you know, if you're still struggling, you're going to need to use that factor flow chart. You're also going to need to use the factor and multiple chart. Okay, if you're having trouble with these numbers to figure out what factors go into things, so if you just look at 15, 1 and 15 are on there, 3 and 5 are on there. That's going to help you remember which ones go together. Okay, so steps for factoring. Steps for factoring. You're going to take out your factor flow chart, your what? Factor flow chart. I think I've been going a little quickly with the words and you guys are taking notes. I'm going to try to slow down a little bit. Take out your factor flow chart and you're going to look for a GCF. Look for a what? A GCF. Step 2 is to determine how many terms there are. How many what? How many terms there are. Okay. If there are 3 terms and your A value is 1, you're going to use the diamonds or general factoring method. Or general factoring method. Okay, and if you're using general factoring, you're going to set up your diamonds or X. It usually just looks like an X for me when I do these. Set up your diamond with the given information and solve. Okay. And then the last step is to make 2 sets of parentheses with X as the first term. Or M or whatever we're using. You can see we have M, we have T down here. So whatever variable you're using, you would use that for. Okay? All right. So let's do a couple examples together here. I think we'll do 2 and 4 together. Then you guys will try 1 and 3 on your own. Okay? So number 2. So what we're doing, we're looking for factors of, on the top is going to be factors of A times C that add to B is going to go on the bottom. Remember, we have AX squared plus BX plus C. Okay? So what is our A, B, and C for this problem? Well, our A is going to be what's in front of M squared, which is just a what? There's nothing there, so it's going to be a 1. Our B is going to be what? -2. And our C is going to be -15. That's just going back to quadratics a while ago. So remember, this is a formula for quadratics, all right? And then, the numbers in front of the variables or by themselves for C are going to be what those are. So then A times C, well, what is A times C is going to be 1 times -15, which equals just -15. And what you'll find for these general factoring problems, since A is always 1, A is always going to be 1. You don't even need to do A times C anymore. It's just going to be A times C is just going to be whatever C is. All right? So you don't need to do A times C every time. You can just put, if you want to, we can just ignore all this stuff and just put C on top and put B on the bottom. B is -2. Okay? So let's just do that for now. Let's just not confuse ourselves here. Okay? So I'm just going to put B on the bottom and C on the top. I'm going to erase this stuff so I don't confuse you. Okay? The other stuff will be important when we get to more complicated stuff. So put C on the top and put B on the bottom. All right, so we need numbers that multiply to negative 15 and add to negative 2. So what are some numbers that multiply? And I'm going to put negative 15. We're going to find numbers that multiply to negative 15. So we always have 1 and 15, but this is a negative number, so which one of these needs to be negative, right? So let's do negative 1 and 15. We can also do 1 and negative 15. Either way works. What else multiplies to 15? 3 and 5. So we have negative 3 and 5, or 3 and negative 5. So we need a combination. We need to add these or any of these four couples here, and they need to add to negative 2. So which of these couples here adds to negative 2? Well, negative 1 and 15 adds to 14. That's probably not going to work. 1 and negative 15 adds to negative 14. That's not going to work. This is 14, so negative 14. What's negative 3 plus 5? That is 2. And what is 3 plus negative 5 going to be? That's going to be negative 2. Okay, so that means we're going to use 3 and negative 5. Okay? So I'll write down here 3 plus negative 5 equals negative 2. Okay, so we need factors of C that are going to add to B. So we need the numbers that are these pairs right here, these pairs that are going to multiply to the top and add to the bottom. We can see that's going to work. And then when we're done, this is a very common thing. Now listen to me very carefully here. People just put 3 and negative 5. They think that's the answer. That is not the answer, okay? It's not the answer. It's like part of the answer. The answer is not just 3 and negative 5. It's going to be m plus 3. You're just going to put whatever the numbers are right there. M plus 3 times m minus 5. That is the final answer, okay? And the reason why this is the answer is because what we're trying to do is we're trying to undo FOIL. And if you were to refoil this again, you'd get back to this original problem right here, okay? That's what we're trying to do. We're not trying to guess what numbers work. That's not the answer. The answer is we're trying to undo what's happening to, we're trying to undo this and get back to a FOIL-looking type thing, okay? We're trying to get to two binomials. So the final answer is going to be m plus 3 times m minus 5. Okay, let's do one more together here because this is still kind of tricky. Let's do number 4. All right, we need factors of C that add to B. Well, what is C in this case here? C is going to be 5. Factors of C that add to B. And what's B going to be for this one? Negative 6. So we need factors of 5, but look down here. We have a negative down here, okay? The only way to get a negative is if both numbers are negative. So what numbers multiply to 5? Well, we got 1 and 5, but what to multiply to positive 5 but end up with a negative when we add them, what do they both have to be? They both have to be negative. And this one's actually a pretty easy one. We got negative 1, negative 5. Do those both multiply to 5? They do. Do they both add to negative 6? Negative 1 plus negative 5, does that equal negative 6? It does. So that's good. And now our final answer, again, we're not going to just put, if you put this down, I'm going to point and laugh at you like I talked about in class, okay? That's not the answer. The answer is going to be x, whatever this number is going to go in there. If it's just a positive, you just put a positive. But it's going to be x minus 1, x minus 1 times x minus 5. And that is our final answer. Okay? I'll leave the video paused right here so you guys can see your work. Why don't you guys go ahead and try example 1 and 3 on your own. Give it a try. All right, welcome back. So we have number 1 here. So we're looking for, remember, C is going to go on top, B is going to go on the bottom. And we have C was what number up here? Was it 1, 12, or 20? It was 20. And B was what? B was 12. And this one's kind of nice because we're multiplying to a positive or adding to a positive, so both numbers have to be positive, which is kind of nice. We're going to do 20. Factors of 20, we can always do 1 and 20. What else multiplies to 20? Got 2 and 10, 4 and 5. So we need numbers that are going to multiply to 20 and add to 12. Which of these numbers here, if we add them, are going to add to 12? Can you guys see? Yeah, 2 plus 10 is going to equal 12. So that means we're going to do 2 and 10. And our final answer is going to be x plus 2 times x plus 10. Okay, now don't write this down real quick. I'm going to show you what we're doing here, why this is important. Okay, I'm going to FOIL this real quick. I'm going to FOIL this. So we get x squared. X times x is x squared. X times 10 is 10x. 2 times x is 2x. And 2 times 10 is 20. And if we combine like terms, these are the like terms here. We got x squared plus 12x plus 20. Do you see how we got the same exact answer? Why this is important? We're trying to undo FOIL, so we got back to the original problem here by doing this, okay? So that's what we're trying to do, is we're trying to undo FOIL, we're trying to undo distribution to get back to the original problem. I'm going to go back a bunch of times. Sorry. Oops, too far. Okay? So that is the final answer, is x plus 2 times x plus 10. Here's the next example. All right, we need numbers that are going to multiply to c and add to b, and c was -6 and b was 5. Okay, so we need numbers that multiply to -6. What numbers multiply to 6? Well, we got, or -6. We got 1 and -6, or -1 and +6. We got 2 and -3, or we got -2 and +3. And these are just factors, guys. These are just things that multiply to 6. And then you got to figure out, if you have a negative here, you need a combination of both. Because to get a negative through multiplication, either one or the other has to be negative. So either these need to be negative or these need to be negative. That's why we have both combinations there, okay? That's why we're doing that. Okay, now we need the right combination that's going to add to +5 down here. So which of these combinations here are going to add to +5? Can you guys see? Yeah, it's going to be -1 and 6. -1 and 6 is going to add to +5. So now our final answer is going to be, it's going to be t minus 1 times t plus 6. And that's our final answer. If you were to FOIL that again, like I said, it's going to get back to the original problem. All right, so let me just double check here that I didn't goof anything up like everything else in my life. Okay, sounds good. Last couple examples here. You guys are doing great. Solving a quadratic equation. We'll use the process we learned in 10.4. You guys didn't talk about 10.4 yet, but that's okay. It's called zero product property, or ZPP. And basically what the ZPP says, guys, if we have A times B equals 0, what needs to be true to get 0 through multiplication? What needs to be true about one or both of the numbers? What needs to be true about one or both of the numbers? Either A needs to equal, we're going to put then, I'll erase that. If A times B equals 0, then A equals 0, or what? B equals 0. That's all the ZPP is trying to say. Either A equals 0 or B equals 0. Okay, so just keep that in mind for when we're doing these problems here, right? So now we're gonna do some actual factoring and some actual solving. So we have x squared plus 7x plus 10 equals 0. Let's use this nice sea foam green. So now we're gonna have to make our own like diamond problems here. Okay, so we're gonna make our little x here. Let's use the actual line function. So we need factors of c that are going to add to b. So what's going to go on top here? What's our c? Our c is 10, and our b is 7. So we need factors of 10 that are going to add to 7. Well, what multiplies to 10? And these are both positive, so both of them are going to be positive, right? So what multiplies to 10? We got 1 and 10. We also got 2 and 5. So what numbers multiply to 10 and add to 7? Well, you're going to have 2 and 5. So if we have our final answer is going to be, this is going to be x plus 2 times x plus 5. Okay, and we're going to go back to the original problem over here. Okay, so this is the most important part, is this stuff right here. The last part's really not that tricky, but it just can seem like an extra step. It's just an extra step, okay? So don't overthink this here. So we're going to put x plus 2 times x plus 5 equals 0. So the zero product property says if this entire thing is 0, then either this equals 0 or this equals 0. So all we're going to do is we're literally going to take each part, x plus 2 equals 0, or x plus 5 equals 0. I don't know if you remember a while ago with like, we did absolute value equations and stuff, or we did and or, like sandwich and oars of a boat, stuff like that. It's kind of like that, okay? So if you have this entire thing equals 0, then all you got to do is set this part equal to 0 or this part equal to 0, and you got to solve. So how do we solve for x here? We're going to do what to get x alone? We're going to subtract 2, x equals negative 2, or how do we solve for x over here? We're going to subtract 5, x equals negative 5. And this is our final answer. Okay? We got to make some room for this other one. All right, and there's a problem with this last one here. Can you guys see what the problem is? So when you're solving a quadratic equation, you need to have it equal to 0. Is this equal to 0 right now, or is it equal to something different? It's equal to 27. So what I'm going to do for this one is I'm going to get the 27 on the other side. How do I move 27 to the left-hand side? I'm going to subtract 27 from both sides. M squared minus 6m minus 27 equals 0. Okay. So now we have it equal to 0. We have a quadratic polynomial we're working with here. We're going to make our diamond, or x. We got c is going to go on top, b is going to go on the bottom. What's going to be our c? Our c is going to be negative 27. Our b is going to be negative 6. So now we need factors of negative 27 that are going to add to negative 6. So what multiplies to negative 27? Well, we got 1 and negative 27, or negative 1 and positive 27. What else multiplies to 27? 2 doesn't go into it, is 3. 3 times negative 9, or negative 3. That was embarrassing. Negative 3 times 9. Okay. Anything else going to 27? I don't think so. And so which of these, if we add these, are going to add to negative 6? Can you guys see? You guys can just test them all. Use your calculator on your phone if you want. But I think the ones that are going to work are 3 and negative 9. So this is going to factor. Factor means we're going to break it down into smaller parts. We're going to undo a distribution, undo FOIL. We're going to unfoil. So it's going to be m plus 3 times m minus 9 equals 0. All right. So now that we have this, remember, if this entire thing equals 0, we're going to set this equal to 0 or this equal to 0. So we're going to literally do that. We're going to do m plus 3 equals 0, or m minus 9 equals 0. Then we're going to solve it. How do we solve for m plus 3 equals 0? We're going to do what? We're going to subtract 3. M equals 0 minus 3 is negative 3. Or how do we solve for m over here? We're going to add 9. M is going to equal, what's 0 plus 9? It's going to be positive 9. So the answers, and this is what the actual answer is. If I plug in that into the original problem, let's just plug it in really quick. Just follow along with me. Don't do the work. So we had m squared minus 6m minus 27 equals 0. So that's going to let's plug in 9. So we got 9 squared minus 6 times 9 minus 27 equals 0. So it's going to be 81 minus 54 minus 27 equals 0. Let's just plug it into a calculator here, make it easier. 81 minus 54 minus 27. Yep, and we get 0 equals 0. So a solution to a quadratic is what makes the whole thing equal to 0. So those are our final answers, are negative 3 and 9. If you plug into the original problem over here. Okay? You could also over here plug in negative 2. So it would be negative 2 squared plus 7 times negative 2 plus 10 equals 0, which would be 4 minus 14 plus 10, which equals 0. That'd be negative 10 plus 10 equals 0, which is 0 equals 0. Okay? So yeah, so basically we're looking for zeros. That's what this is kind of called. So just these last couple of problems are pretty tricky, but mostly the most important thing from this lesson is just to be able to factor and do this thing where we like figure out what the the unfoiling thing was for this, okay? So don't be too whacked out by these last couple problems. They will be important later, but for now, as long as we know how to do the factoring, I think we'll be okay, and we will spend extra time if we need to on this stuff to make sure you guys feel good about it, okay? I'll record another video if I have to. Okay? Thank you guys for watching. I hope you have a terrific day, and we will talk soon.